You try. Let's see how you did. I got x cubed minus 5x squared greater than or equal to 9x minus 45. So it needs to be in standard form first. So subtract your 9x and add your 45 over. Subtract your 9x, add your 45. Remember that you can only do these to like terms, and that means that we're just rewriting this in standard form from highest exponent down to lowest exponent to the constant with the greater than or equal to 0. So there's our guy. You have factor theorem, rational roots theorem, synthetic division, or factoring. I'm going to take out a GCF on the left, which leaves me with x minus 5. I'm going to take a GCF out on the right, which is going to leave me x minus 5. And, of course, I'm going to combine my two GCFs and make a brand new factor. This is called factor by grouping. We did this already. If you don't remember it, go back and take a look at the Nearpod for factor by grouping. We did a ton of these at the beginning of the school year. This is a difference of two perfect squares like our example. So you're going to break that into x plus 3 and x minus 3. And then, of course, bring down your x minus 5. And that's all greater than or equal to 0. So what you've done is you've got it in standard form, then started factoring and breaking it apart. And now we're down to our roots, which is at x equals negative 3. X equals positive 3, and x equals 5. It feels so good to be able to get these answers without much difficulty. We're going to take our y-intercept, and that's 0, comma, whatever your constant is, and our constant was 45. This is a cubic with a positive a value, which means that I'm anticipating when I sketch this that I start bottom left and I move top right. Little wiggle in the middle. Let's look at our scale to make our sketch. We need a negative 3, we need a positive 3, and we need a positive 5. 45's got to go up top. And we have to pay attention to whether it's an open or a closed circle. In this case, it's a greater than or equal to. This tells me that it's going to be solid dots because of the equal to. So I've got solid here, solid here, solid here. I know that I'm starting bottom left and moving top right. So I'm going to start here, go up through the 45, come down through the 3, and up through the 5. So there's our sketch. The next thing we have to do is check out our inequality. This says greater than or equal to 0. Greater than means all the values of y that are more than 0. So what we're looking for is where does this graph peak above the x-axis? So I'm looking for some sections that go above the x-axis. I've got one right here from negative 3 to positive 3. There's a big lump that goes above the x-axis. These are the x values that produce y values that are bigger than 0. We also have another one over here. These y values are bigger than 0. So all of these values of x are going to make the y's greater than 0. So these are my two sections for my inequality. Those are the solutions. Because it's solid, because there's an equals, we are using a square bracket with a negative 3, comma 3 for our first section because they're solid. Union, our second section, starts at 5 and goes to infinity. And don't forget that infinity is always a parenthesis. And this is your final answer for your cubic.